Hello friends, in this video we will talk about lattice planes, Miller indices and Weiss indices. So first of all, come to the lattice plane. Crystals are consisted of a large number of imaginary parallel planes. These are called lattice planes. Now this is my crystal lattice. I can consider a different combination of parallel planes passing through these lattice points. Now consider it. This can be my first combination. This can be another way to introduce lattice planes, or even you can think these planes as your lattice planes, or even you can take any other combination. So from a given lattice, from a given crystal lattice, you can get an infinite number of parallel planes. These are lattice planes. Now, what is Miller indices? Miller indices are determined by the three numbers H, K, L, which represent the ratio of the reciprocal of the intercept of three axes x, y, and z. That means if you take this, look at this, the intercept of this plane is at x equal to 1 and y equal to infinity, z equal to infinity, because this plane is not cutting y and z axis. That's why the 1, infinity and infinity will be the Weiss indices and Miller indices will be its reciprocal. Now what is Weiss indices? Actually, Weiss indices are ratio of the reciprocal of Miller indices. So Weiss indices and Miller indices, they are interlinked. If you just take the reciprocal of Weiss indices, you will get the Miller indices. This is my 100 plane of a cubic lattice. This is 110 because this plane cuts x-axis at x equal to 1 and y-axis at y equals to 1. But this plane doesn't cut the z-axis. This is the representation of 111 plane, where this plane cuts all the three axes at unity. So I have just shown these three pictures in the next page. Now look at this carefully. Here, my Weiss indices are 1, infinity and infinity. That means this plane is cutting x equal to 1 and y and z equal to infinity. So what about this plane, which is cutting the x-axis at x equals to half? So if this plane is 100, the Miller indices, then the Miller indices of this plane, which I have just shaded, and this will be 200. Because in this plane x is equal to half, y is equal to infinity, z is equal to infinity. Now come to an example. If a plane cuts three axes at x equal to 5, y is equal to 2, and z is equal to 1, then what will be the Miller indices of that plane? So the intercepts are given, okay, x equal to 5, y equal to 2, and z equals to 1. So we have to take the reciprocal of this. So this reciprocal will be 1 by 5, this will be 1 by 2, this will be 1. And the ratio of the reciprocals is equal to this 1 by 5 is to 1 by 2. This is to 1. Now we have to multiply 10 on each side. So we will get 2 is to 5 is to 10. So the Miller indices are such that HKL is equal to 2, 5, 10. This will be the Miller indices of that plane. Now think, if the Miller indices are given, you have a plane which has the Miller indices 1, 2 and 2 bar. This bar represents that the plane is cutting that axis at negative end. That means in case of 2 bar here, the plane is cutting the z-axis at negative end. Now we have to find out the intercept. The Miller indices are given and we have to find out the intercept of that plane. So first of all, take the ratio of the reciprocal. So ratio of the reciprocal. The ratio of the reciprocal 1 is to 1 by 2 is to 1 by 2. And there is a bar. That's why this will be negative. So now the ratio, multiply 2 on all sides. So we will get 2, that is to 1, that is to minus 1. So the intercept is at x equals to 2, y equals to 1, and z equals to minus 1. So if this is my x, this is y, and this is z, the plane will cut x at 2. Here x is equal to 2, y at 1, and z at negative 1. Like this. So this was for this video. In the next video, we will learn the d-spacing formula and the formula for determining the density of a unit cell. Thank you for watching.